Here we go. 2 vocab words. What are the 2 vocab words, guys? Same again. One more time, same one more time. That was better. Independent and dependent. So first, I'm going to show you dependent event. So we've got this bag. This bag has how many marbles in it? Right here, do you see how many are going in? 3 marbles. How many of them are green?
2.
How many are purple? So what we're pretending to do is we're dropping just 3 marbles in the bag. What you're going to do is you're going to pull 2 out at once. Actually, let's say you pull 1 out and then you pull the second one out. You okay with that idea? So if you pull 1 out and then you pull the second out, I'm going to say this is a dependent event. Because if you pull out a green one first, how many greens are left in the bag? If you pull a purple one out first, how many greens are left in the bag? So one of them has a better chance of getting a green on the second try. So if you want a really good chance of getting a green on the second try, what would you hope to pull out first? I heard both green and purple. One of them is better. What do you think? You want purple first, right? Because if you pull the purple out first, how many greens are in the bag?
2.
2, so you have a better chance. Do you see how it's manipulated by the first one? Dependent events are dependent, literally that word, on what you pull first. So if you want a really good chance or perfect chances of getting a green, you would hope for the purple first. Now, if you don't pull the purple first, you pull a green. So the green, one of the greens is now out, right? What's left in the bag? So what are your chances of getting a green? 50-50, right? It's just a, oh, I hope. And then you have a 50-50 chance. So let's go over those 2 vocab words, independent and dependent. So first, will you write those 2 words on your scratch paper? And then let's get down some definitions. So we've got an independent event. Write that down first. Let's talk about that one. While you're writing it down, because I think independent, I think of a living situation. You are independent if you have moved out of your parents' house. Does that make sense? You are on your own, you've got a big boy job or a big girl job, you pay your own bills, you are independent. Now you guys technically right now are dependent on your parents, right? They feed you, they clothe you, they give you somewhere to sleep. But hopefully you'll grow up and you'll get out of your parents' house and you'll be independent, right? It's the same thing for these. Okay, you ready? So independent event does not depend on the first outcome. Okay, let me think of an example for you that I hope you can wrap your heads around. Okay, example, experimental probability of flipping a coin. I'd say this is independent. If you flip a coin, what could you get? Okay, the second time, if you flip a coin, does it matter what you got first time? No, it's not like the coin is like, oh, I got a heads, I better not get a heads. The coin doesn't have a mind to think, right? So, and it's always the same, heads or tails, it doesn't matter. So example of an independent event, flipping a coin is always independent. It doesn't matter whatever you flipped the first time. Okay, so that's one that's always independent. What if we had the marble question? How can we make that independent? Oh, I have it. You have a bag of marbles. Let's do the same. We have the green, and the purple, like before. It can be independent, but here's the only way to make it independent. If I gave Gage the bag, and I'm like, hey, Gage, take out a marble. So he takes out a marble, maybe he gets the purple, and he's like, yeah. Then he has to put it back. If he puts it back and I give it to Skylar, does it matter what Gage got? And then if Skylar puts it back and then I pass it to Isabella, does it matter? No. So the key word to make other ones independent is this. I'm going to write it off to the side. Putting it back. There's a way to say that in probability. Putting it back is called with replacement. You replace whatever you took out. Then it's not going to affect the next person who plays the game or draws the marbles or picks a card. You have to put it back, and then it stays the same. Go ahead, Skyler. You totally could. Bunch of different colors as long as you put the color back, right? Okay, so dependent, let me move this up a little bit. Dependent depends on the first outcome. So we can do the exact same definition, only opposite. So this one does depend. on the first outcome. You know, I really liked how you girls underlined on the warm-up, so I'm going to underline this. Independent does not depend, and dependent does depend. Okay. I think of an example though. You have an example, Jacob? Go ahead.
It's pretty much just like the marble one we did, except they don't put back the marble.
Okay, so if it's going to be dependent, he said we could use the marble example. If we don't put back the marble, is that dependent? So if I passed Corbin the bag and I said, Corbin, take a marble, but he kept the marble, and then I passed it to Cecily, does it matter what Corbin picked?
Yeah.
Totally does. So like Jacob said, let's put marbles, but you keep them. So draw the marbles, but you keep them. I have to go backwards. So draw a marble, but keep it. Okay, improbability, there's a way of saying keep it. It's kind of like we wrote in dark blue. That one was with replacements. What do you think this one is? Perfect. Write it down. Way to figure that out. Max, is that what you're going to say? Perfect. So this one is without replacement. Don't put it back. A big section of today's assignment is deciding, can you tell whether it's independent or dependent? So I just think, am I putting it back? Or does it matter, whatever the first person got? Okay, the next part. Oh, yeah, this one. We talked about this. So flipping a coin, what are the options we could get? Heads or tails, right? That's 1 out of how many options? 2. So heads, 1 out of 2. Tails, 1 out of 2. This one is saying you're going to flip 2 coins. If you flip 2 coins, is this going to be independent or dependent? Independent. So if we flip this coin, we flip it and we mark it. And then we flip this coin, we flip it and mark it. Does this second one matter what we got on the first one? No, coins can't tell the difference, right? So this one is totally independent. Okay, but I have a question for you. Actually, I think I put it on the next page, but we're going to use this. Okay, so we flip the coin. Oh, no, it's not. How many possibilities are there of getting heads?
1 out of 2 out of 4.
I heard 2 out of 4 and I heard 1 out of 4.
1 out of 4.
I'd say there's only one way of getting a heads. Do you see that? 1 out of 4. Do you have that decimal memorized yet? 0.25, which is what percent? 25%. Okay, let's go to this one. I put 2 events together. So we're going to flip a coin. Stop. How many options are on a coin?
4.
On a coin? 1 coin? 2 options, right? And then I'm going to have you pick a number from 1 to 4. How many options of numbers 1 through 4? 4, right? So make a tree diagram of the flip and the draw. Okay, get ready. Stay with me. Let's do the numbers first. So let's just put card number 1, card number 2, card number 3, card number 4. Yeah, we're going to do the tree right now, Gage. Just follow with me. Okay, so I hold up 4 cards. And then I'm like, all right, Kaylee, choose a card. So she chooses one. Maybe she literally gets 1. But then she has to flip a coin. So after she gets card 1, she flips a coin. And what could she flip? Okay. All right, but maybe I went to Michaela. And I said, Michaela, choose 1. She chooses. She happens to get 2. But then she has to flip a coin. What does she get? Heads or tails? Then I go to Corbin. Corbin would get heads or tails, right? After he chooses maybe the number 3. And then Jaden, maybe she gets the number 4. She would still get heads or tails. Okay, how many total outcomes are there? Do we agree with 8? All right, let's write that underneath. So 8 total outcomes. Okay, do you have your cute little tree diagram? Because I think the questions on the next page go with this. Let me double check. Okay, using our tree diagram, what are the following possibilities? What's the possibility of getting a tails and a 3? 1 out of 8. So what was it? A tails and a 3? So here's the 3. The only way is 1 out of how many total? 8. So let's write it on our paper. So 1 out of 8. But let's keep practicing fraction decimal percent. So grab your calculators. Just like we did like crazy yesterday. Change that to a decimal. Thanks for raising your hand. Alyssa, what'd you get? Sorry, tell me again. 0.13. Shout it out, guys. What percentage is that? Okay. Way to round it, Alyssa. Thank you very much. Okay, the next one, number 2. What's the probability of getting a tails and an odd number? Okay, I'm going to go back and look. Has to be a tails. Which numbers are odd? 1 and 3. So there's 1 right here. There's 1 right there. So 2 out of how many? Okay, let's write it down. Oh, I like that. 2 out of 8 or 1 4. Yeah, because we can have this one memorized. 0.25. What percent? Oh, yeah. Good work. Me too. I also think of quarters. Okay, heads and a number greater than 3. Okay, so go back. Oh yeah, because the only number greater than 3 is 4, so it'd have to be 1 out of 8. Good work. Oh, it is the same, so let's just copy it down. So 1/8 decimal, Alyssa helped us, 0.313, and 13%. Okay, what do you think about this one? Are these events dependent or independent? Independent, right? Could we make it dependent? Jacob, how would we make it dependent?
You make it so then you would use one number,
Uh-huh.
but no one else could use it.
Perfect. Nice. He said you could use one number, but you'd have to say no one else can use this same number. Good work. Okay, next one. Without a tree diagram, you can still figure out these probabilities. So I'm going to show you. What if you don't have a tree diagram, or you don't have time to do the tree diagram? You can still figure these out. You just got to think yourself through. It says you decide to roll a die. Stop. How many options are on a die? 6. You just got to remember that. So I'm going to write that up here. There's 6 on a die. And then you flip a coin. Stop. How many options on a coin? 2. You got to keep that together. Okay, right here, it says find the probability of each in this order. What's the probability of getting a 4 on a dice? 1 out of 6. Perfect. So this probability is 1 out of 6. You okay with that? Stop and separate heads. What's the probability of getting a heads on a coin? Okay. Will you write these down, and I'm going to show you how you can figure out the probability. Don't zone out. It's really easy, but if you zone out, you'll miss it. Don't zone out. Okay, you got it? All you have to do is multiply. That's it. Okay. But then after I said that, my last class was like, oh, I got this. So that would be 2 8s. No, not even kind of. And they add their fractions wrong. If we're adding, we're not adding, we're multiplying. The rule is so easy. Repeat after me. Top times top, bottom times bottom. Say it again. So what's 1 times 1? What's 6 times 2? That's it. Write it down now. Change it to a decimal and a percent. Top times top, bottom times bottom. And then change it to a decimal and a percent. Help me out if you have it. Will you raise your hand? Please. So what? Well, it's got to be little. Kaylee, thanks. What'd you get?
I got 0.08.
0.08. So that would have to be 8%. How many got the same thing? Okay, let's do the next one. So stop and do this probability first. Greater than 2 on a die. Shout it out. How many options?
4.
4, right?
Yeah, 4.
Because 3, 4, 5, 6. Yeah, 4 out of.
6.
Should we simplify that?
2/3.
Let's simplify it to 2/3 or 2/3.
Because when you're multiplying it, it's easier.
Yeah. Okay, tails on a coin. What's the probability? 1/2. Stop. Nice and loud. What do you do with these two probabilities? Thank you. No. I heard cross multiply. It's not cross. Just multiply. What's the rule for multiply?
Top times top, bottom times bottom.
That's it. Top times top, bottom times bottom. Top times top, 2 times 1. Bottom times bottom. It is 1/3 max. Do you have this decimal memorized? Maddie, what is it? Go ahead with your question. No, because you'll get the same decimal, same percent. All right. What did you get? Michaela, what'd you get? Perfect. Let's do 0.33. Round it to the hundredths, so that'll be 33%. So when you have more than one probability, we always multiply. What's the rule for multiplying? Not too bad, right? Just don't forget. I love these questions. Okay, so we're going to pretend we're putting all of these letters in the bag, shaking them up, and then we're figuring out the probability. So, what's the probability, just right here, underline this, what's the probability of drawing a letter M?
2 out of 11.
Is it 1 out of 11 or 2 out of 11?
2 out of 11.
There's 2 in there, right? So that first one is 2 out of 11. Okay, now here's the key word. You're putting it back. So put it back, shake it up. Now, what's the probability of getting an M? Right? Because there's still 2 in there because we put it back, and there's still 11 in there because we put it back, right? So 2 out of 11. What do we do with these 2? Times them. You still with me? What's 2 times 2? 11 times 11? It is 121. Grab your calculators, change it real quick. Decimal and percent. What'd you get, Jack?
0.03.
Thank you, Jack. 0.03. 3%. Here's my bigger question. Hand in the air. Is this independent or dependent? Kennedy, what do you think? Dependent. What do you guys think? Did the first outcome affect the second outcome? We put it back. If we put it back, it's independent because we put it back, right? Okay, number 2. All right, so number 2 says probability of drawing them. We already did that. What's the probability? 2 11s. Here's the key word though. This time you keep it. So what's going to happen to the next one? If you keep it, now how many letters are in our pretend bag? There's 10, right? Now how many M's are in there? Because we kept the first one, right? So times this. What's 2 times 1? 11 times 10?
110. And then you simplify it.
155. All right, doing great. Does anybody have the decimal and the percent yet? Oh, Kaylee, go ahead.
There'd be
0. What was it? 18. Is that what you guys got? Oh, it to 0.02. Is that right? 2%. Okay, so this one, if we kept the letter M out, it affected the next one, right? So is this independent or dependent? It depended on the first one, so this is totally dependent. Good work, good work. Okay, this one, open up your book.